Good morning, dear students. Today I'm gonna make a correction for your homework. I'm sorry, I have a bad handwriting. Okay, let's see our homework. Our homework was a pupil book, page 8, exercise 1-1, and we have complete the following. So let's see number 4 because we already answered before number 1, 2, and 3. Number 4 says if nx2 equals 9, which means that the number of ordered pairs in the Cartesian product of x and x equals 9. Then nx, which means that the number of elements in the set x equals. We have here the number of ordered pairs of x2, so the number of ordered pairs in x is the square root of the number of ordered pairs in x2. So the answer here in the first one, number 4, is that nx equals square root of 9, which is 3 elements. Okay, next question was if the Cartesian product of x and y is 2 and 9, 2 and 6, 2 and 9, 3 and 6, 3 and 9, 5 and 6, 5 and 9, then x equals and y equals. We said before that the Cartesian product of any two sets produces order pairs, and the first projection of this order pair is an element of x, and the second projection of this order pair is an element of y. So the element of set x will be 2, we have another 2 here, 3, and we have another 3, and 5. Let's write this first. So x equals 2, 3, and 5. Okay, what about y? The second projection of the ordered pairs is an element of y. Okay, so the elements of y are 6, 9. We have 6 and 9 here, we have 6 and 9 here. So I'm gonna write that y equals 6 and 9. Okay, the second question is choose the correct answer. And the homework was number 1 and number 2. Let's see the first one. If nx equals 3 and n of the Cartesian product of x and y is 12, so n of y equals. Remember the rule that says that n of the Cartesian product x and y equals n of x multiplied by n of y. So we have here the number of ordered pairs of the Cartesian product x and y, it's 12. So I'm going to write here 12 equals, and n of x, it's 3, which means that the number of elements in set x is 3. So I'm going to write here 3 multiplied by n of y. I want to get the value of n of y. It's a simple equation, so n of y equals 12 divided by 3. So the answer is 4 elements. Okay, next question says if the ordered pairs 3 and 5 belongs to the Cartesian product of two sets, You see these two sets? The first set is 3 and 6, and the second set is 8, x and 8. So what's the value of x? Okay, the Cartesian product of these two sets produces a set of order pairs. The first order pair, for example, is 3 and x. The second order pair is 3 and 8. Another order pair, 6 and x, and 6 and 8. So now the first order pair that we said it is 3 and x. What's the value of x? Remember here that the order pair 3 and 5 belongs to this Cartesian product. And we said that the first order pair is 3 and x. So the value of x actually will be 5. So I'm going to write here number 2, x equals 5. Okay, let's have another paper, and let's see question number 1 here. In the boys class, there is homework on number 1, but in the girls class only number 2. Actually, I remember number 2 and 3, yes, but in boys class it's 1, 2 and 3. Let's answer. The question says, if x equals 2 and 3, y equals 3, 4 and 5, then find the Cartesian product of x and y, and represent it by an arrow diagram and Cartesian diagram. Okay, let's first find the Cartesian product of x and y. We have two sets, x 2 and 3, and y it's 3 and 4. Okay, so question number 1, we have x, let me write x here, it's 2 and 3, and we have here y, which is 3, 4 and 5. Okay, let's use another color here. So the Cartesian product of x and y equals, yes, right, it's 2 and 3, 2 and 4, and 2 and 5. Sorry, I'm gonna erase this. So it's 2 and 5. Okay, another order pair, yes, it's 3 and 3, 3 and 4, and 3 and 5. These are the order pairs of the Cartesian product x and y. Okay, the question says represented by an arrow diagram and the Cartesian diagram. Okay, the arrow diagram, I'm going to write an oval here for x. I put the elements of x, they are 2, 3, and another oval for y. The elements here are 3, 4, and 5. So the first order pair here is 2 and 3, so I'm gonna join an arrow from 2 to 3 like this, and the second order pair is 2 and 4, so this is 2 and 4, and the last one here is 2 and 5. It's not the last one for the Cartesian product, I mean the last one for the elements 2. The element 2 has 3 arrows with the elements of y. Okay, we have another order pair here is 3 and 3. Let's use another color. So this is 3 and 3, 3 and 4, and 3 and 5. So we represent the Cartesian product of x and y by an, we said, arrow diagram. Okay, now let's represent the Cartesian diagram of x and y. Actually, I'm not good in drawing using rulers, so I'm gonna use here. I have a simple ruler here. I'm gonna use another color here. So we have first axis here, and we have the second axis here. Okay, the Cartesian product of x and y is represented by two axes, and the horizontal axis for the first set, which is x, and the vertical axis is for the second set, which is y. Then I'm gonna put the numbers of x, 2, and 3 with equal distance starting from here, from the origin. So this is 2, and I'm gonna move another distance which is equal to this distance. So this is 3. And also for y, I'm gonna put 3, 4, and 5 in equal distances. I'm gonna put here is 3 and move another distance which is equal to this one. I'm gonna put 4, and here is 5. Okay. The first order pair here is 2 and 3. So 2 and 3, I'm gonna put a small point which refers to the order pair 2 and 3. And the second order pair is 2 and 4. I'm gonna put another point for 2 and 4. The third order pair is 2 and 5, so this is 2 and 5. Okay, where's 3 and 3? Yes, this one is 3 and 3, and 3 and 4. This one 3 and 4, and this is 3 and 5, and this is, we call it the Cartesian diagram of the Cartesian product x and y. Okay. Okay, we have simple questions here about n, x, and y, which is the number of order pairs of x and y. So the answer here is, actually we know 2 elements and 3 elements, so the number of order pair is 6. If you count them, you'll find that they are 6. Let's use red color. This is letter A, and for letter B, number 1, the answer is 6 ordered pairs. And ny2, which means the number of order pairs of y2, and the number of elements of y is 3 elements. The number of the elements of y is 3 elements. So the number of order pairs of y2 will be, yes, 9. So number 2, I'm going to write here 9 order pairs. Please, if you don't remember the rules, open your classwork, check your classwork about all the rules that we said about the Cartesian product and the number of order pairs and blah blah blah. Okay, here it says the Cartesian product of x and y intersect y2. This is a very good question because this question is 2 parts. This question contains 2 parts. The first part is x times y, and the second part is y2. Then the final answer, I'm going to find the intersection of these 2 Cartesian products. Okay, let's answer this. Number 3. We have here x, the Cartesian product of x and y, and the elements or the order pairs here are 2 and 3, 2 and 4, 2 and 5, 3 and 3, 3 and 4, and 3 and 5. So now I'm gonna find y2, which means the Cartesian product of y and y. And we have y here. How many order pairs? Yes, we said it before, 9. Okay, let's write the order pair. The first one is 3 and 3, 3 and 4, 3 and 5. What else? Yes, 4 and 3, 4 and 4, and we have 4 and 5. What else? Yes, 5 and 3, 5 and 4, and 5 and 5. Now, let's answer now. We have the Cartesian product of x and y, and y2, and I want to find the intersection, which means the common elements in x and y and y2. So the intersection of these two sets means the common elements. Okay, let's check the common elements or the common order pairs. The first common here, I can check it, is 3 and 5 here in the Cartesian product of x and y, and we have another 3 and 5 here. What else? Yes, 3 and 4, and we have here also 3 and 4. Yes, we have also here 3 and 3, and here is 3 and 3. So the common order pairs of x, the Cartesian product of x and y2, will be 3 and 3, 3 and 4, and 3 and 5. Okay, another question here, number 2. Okay, let's have another page. We have here, if the Cartesian product of x and y is 1 and 1, 1 and 3, 1 and 5, then find x and y. Simple question. X will be 1 because we have the first projection here is 1. So I'm going to write the answer. I'm going to use blue one. Question number 2. Letter A. X equals 1. Okay, what about y? Y, the elements of y, which are the second projection of the Cartesian product. So 1, 3, and 5. 1, 3, and 5. Okay. Letter B says the Cartesian product of y and x. I think all of you know the difference between the Cartesian product of x and y and the Cartesian product of y and x. We are gonna switch the order pairs. So the first order pair in the Cartesian product y and x is 1 and 1. And the second one is 3 and 1, and the last one is 5 and 1. Okay, I'm gonna write them here. The Cartesian product of y and x, they are, I'm gonna write it from here. So the first one is 1 and 1, 3 and 1, and the last one is 5 and 1. Finally, y2, which is the Cartesian product of y and y. This is letter C, y2. How many order pairs we are going to write? Check the number of elements here. There are 3 elements, so we have 9 order pairs. 9 order pairs, 1 and 1, 1 and 3, 1 and 5, 3 and 1, 3 and 3, and 3 and 5. I'm sorry, it's not and. We have another order pairs, which are 5 and 1, 5 and 3, and 5 and 5. This is 5 and 5. Uh, Question number 3. If x equals blah and blah, y equals blah and blah, z equals blah and blah, then find the Cartesian product of x and y intersect z, the Cartesian product of x difference y and z, and the Cartesian product of x difference y and y difference z. Okay, let's have a new page to answer question number 3. I'm gonna write x here, which is 3 and 4, y, which is 4 and 5, and z, which is 6 and 5. The first question says the Cartesian product of x and y intersect z. This is letter A. Okay, I'm going to use another color. I'm going to find the intersection of y and z, which means the common elements of y and z, which is 5. So the Cartesian product of x and 5, I'm going to write it here, x, which is 3 and 4, and here is 5, and the answer will be the ordered pairs 3 and 5 and 4 and 5. Letter B. The difference between x and z, and or x difference z, the Cartesian product of x difference z and z, x difference y. I'm going to write it here, x difference y. Okay, so first I'm gonna find the difference here, x difference z, and difference here means the elements that belong to x and doesn't belong to y. We have 3, which is belong to x, and x3 belongs to x and doesn't belong to y. So here's the answer is 3. So I'm gonna write here 3 and z, which is 6 and 5. So the answer here is 3 and 6, and another ordered pair, which is 3 and 5. Letter C, let's have a new page. Okay, x difference y, and here's y difference z. So first I'm going to find x difference y, and we said before that the elements belong to x and doesn't belong or don't belong to y here in this page, which is 3. Yes, I'm sorry. I'm gonna write here 3, and y difference z, which means the elements that belong to y and don't belong to z, which are let's check here this page number 4, and oh yes, the elements that belong to y and don't belong to z, it's 4 only. So we have here 4. Then I'm going to write here Cartesian product of 3 and 4. So the answer is the ordered pair 3 and 4. This is the correction of our homework. Thank you very much, and see you soon on Sunday. This is Mr. Ashraf. Bye bye.